You are welcome to this training. This is the first part of a short tutorial series on how to forecast sales or demand and know the effect of an event on your business. We are hoping to be able to upload the second part very soon. So please subscribe to our YouTube channel, INF Network Solution. And if you have any question on the training, you can call us on 081 800 83821. Or maybe you want to join our virtual club, our Data Science for Business virtual club on Telegram. You can also send us your WhatsApp number so that we send you an invite. If you need the data to practice the exact steps that we have here, you can also get across to us through the same number and we'll make it available to you. But you can use any data actually once you understand the process. So we get down to business. Our goal in this training is to be able to provide a better understanding of customers' behavioral patterns before and after a particular event. So let's look at a problem scenario here. For example, if we have a departmental store that is able to store the sales, that's the sales data, periodic sales in form of time, date, and against the amount that was sold, for example, we can forecast the future sales and look for a way to be able to compare that forecast without the events. For example, in this scenario, we are looking at COVID as an event. Okay, so we are looking at a way to actually compare that forecast without that event in question with the actual sales record. So to be able to see the impact, to be able to understand how customers behaved based on that particular event. And an event might not necessarily be negative, it might even be positive. Like maybe you have a promotion and then you want to measure what exactly was the effect of that promotion on your sales. So for the training, we have a short outline here. We introduce ourselves to forecasting briefly, and we will look at a practical problem. So you're going to need the Microsoft Office for this training and 2 sets of data to be able to try out some of the things that is being taught. So introduction to forecasting. What is forecasting? Basically, the idea behind forecasting is to be able to predict the future. And when we are talking about forecasting, there are qualities of a good forecast. For example, it should be timely and reliable. It should be accurate. It should be as accurate as possible. And you should be able to have meaningful units. It should be in meaningful units with respect to whatever data that you have. And then it should be easy, of course, it should be easy to understand in practice. And a good forecast should be more than just a single number. For example, mean, that is not a good forecast, but it should be, it should have variable values so that you can actually see what is going on. Applications of forecasting. Forecasting is used in several application domains. For example, the retail store. What can they use it to do? For example, they can use it to forecast their sales. It's used in the energy sector. Energy companies can actually use it to forecast reserves, production, demand, and prices. It's also used in the educational sector. For example, educational institutions can use it to forecast enrollment. Okay, then governments Government can use it to forecast receipts and spending. So banks, they are not left behind too. Banks and financial institutions can use to forecast home purchases. For example, financial organizations like the World Bank and International Monetary Fund, they usually use forecast, to forecast inflation and economic activity. Transportation companies are not left behind too. They can forecast future travel. So those are the things those are the various applications and so much more. Okay, even a venture capital firm can use it to forecast the market potential and to evaluate their business plan. So there's so many applications of forecasting in the business sector or in any other sector as it were. So types and ways, the types of ways, to be able to model time series data. How can we model time series data? We can either model it using descriptive modeling. And in this situation, we want to be able to describe what exactly is going on. We're going to be doing that just in a minute. And then we can do predictive modeling, or we can combine, different predictive or forecasting methods. So those are the types of ways that we can actually model this time series data. Then when we talk about time series data, what exactly are we talking about? We are talking about the kind of data that you have, like this. You have a kind of data that has probably just 2 columns, and it has a time stamp on it, and then you have whatever measure that you want to measure. So in this case, this ridership, it could be sales, it could be any other thing that you want to measure. But in this course, we're going to focus on forecasting time series value, that single time series value. And of course, time series analysis deals with data with time and measured against different, values. So you have a time, and then you have different values that you are measuring based on that particular time. So descriptive modeling, let's just look at the descriptive and predictive. We're not going to be looking at the third one. So we'll just look at descriptive modeling briefly, and then we'll look at predictive modeling too briefly. Like I said, this is just an introduction. So descriptive modeling. For the descriptive modeling, we use it to determine the components of a particular, time series data. So we want to know, there are several components. We're going to be talking about that later. So in descriptive modeling, what we are doing is we want to determine the components, for example, in terms of seasonal patterns, trends, relation to external factor, and so on and so forth. And of course, this can be used for decision making and policy formation. So descriptive modeling methods, there are some characteristics that it should have. It should be understandable, because we are using it to describe, a particular situation. And then it should usually use exploratory models based on causal arguments or explanatory models. So those are the kind of models that we usually use for descriptive modeling. So now let's talk about the components that we are asked to understand in descriptive modeling. The first one is the level, okay? Level helps us to describe the average value of the series. Trend. Trend is the change in series from one period to the next. Seasonality. Seasonality helps us to describe a short time cyclic behavior. We're going to be seeing examples of this even as we go on. And then we have the last one, that is the noise. So noise is like a random variation that results from measurement error and other causes. So those are the 4 components. So for descriptive modeling in forecasting, we want to explore these components and be able to use it to describe our data and to really understand it and know what exactly is going on. Also in descriptive modeling, that's for in forecasting. We also talk about basic statistics. We call them descriptive statistics. So like the mean that we're already familiar to, that's the average, that's the average. And then we also have the standard deviation. So, and this is the formula for the standard deviation. And what exactly do these simple statistics help us to do? For example, the mean, the arithmetic mean, what do we use it to do in descriptive modeling when we are doing forecasting? So the arithmetic mean helps us to know what to expect the next observation to be. Whatever your average is, okay, then the sales in the future would just deviate from that average. So it gives you a direction of, what your answer should be, or what your prediction or what your forecast should be like. So it should be a variation. So whatever it will be like will be a deviation, from that particular value. That's for the average. But for the standard deviation, what do we use it to do? When we are calculating the standard deviation for our time series data before we start, forecasting and all that, what exactly why are we doing that? Okay, so the standard deviation describes, roughly speaking, how far away actual random values are from the mean or the average. So we want to see what is going on there, okay? So it tells us how spread out the distribution is around the mean. So that's the standard deviation. So, and it also gives us a measure of noise or variation that there is in the data. So so when we are trying to, calculate this for our time series data, that is what we are out looking for. Now, there are so many other things on descriptive modeling, but we're just going to be touching briefly on those. Now, let's go to predictive modeling in forecasting. So for the predictive modeling, we have the model driven, okay? Now, first of all, predictive modeling for time series forecasting uses information in time series to forecast future values of that particular series. Then we now have two approaches. We have the model driven, and for the model driven, it specifies a model. Then it will now estimate, estimate it from the time series data. So some of the approaches that is being used there is the regression-based approach, and that's the one we are going to be using for this short training. Then for the data-driven, it learns pattern from data, unlike the first one that specifies a model and then estimates that particular model from data, but the data-driven now learns pattern from data. An example of such approach is the smoothing method, and one typical example of that is moving average and so many other smoothing approaches. But to decide which one to use, okay, you use the nature of the series. So you want to know whether the series is global or local. So based on that, you know which of these models to use. Now, for the global pattern, let's just quickly touch on the global and the local so that we know how to decide. So for the global pattern, it's one that is relatively constant throughout the series, okay? So an example is a linear trend throughout an entire series, okay? And for global patterns, we usually use the model-driven method for that. Then for the local pattern, okay? The local pattern is one that occurs only in a short period of data and then changes. So an example of that is a trend that is approximately linear within 4 neighboring time points, okay? But the trend changes slowly over time. That's the local pattern. And for this local pattern, we usually use data-driven methods for such. Now, for the third one, which is combining methods, basically, combining forecasting methods can be done via 2 levels, okay? First, you want to That's the first method, uses the original time series to generate forecast of future values. And the second method uses the residuals from the first model to generate the forecast of future errors. Or let me put it like this. It uses the second method uses the residual from the first model to generate forecast of future forecast errors, thereby correcting the first level forecast. So that's when you want to combine the methods. So like I said, we probably will not be looking at that, but we'll be looking at the descriptive modeling briefly and then the predictive modeling briefly. So for the predictive modeling, let's just talk about the regression-based, the simplest regression-based forecasting, and there are several other ways of using this particular regression-based forecasting. So there are three common trends. We have the linear trend, we have the exponential trend, and we have the polynomial trend. And we're going to be looking at each one of them very soon. Then there are two types of seasonality. Remember, we explained what trends are. We explained what seasonality are. We have the addictive and we have the multiplicative, but we're not going with the multiplicative or seasonality. We're not doing that in this short training, but we're going to be doing the first three. So linear trend. What's linear trend? Because we need to actually understand this concept before we start using it for forecasting. So linear trends, the time series with global linear trend is giving us what we have here. So what exactly are these? This value, this YT, okay, is the outcome variable, where T goes from 1, 2, 3, and is the time index. We usually call it period. So it's used as a single predictor in a regression model. Then the B0 is the level, the B1 is the trend, and this value right here is the noise. So the seasonality is not modeled in the linear trend. So now let's look at this simple data description just to be able to understand this formula that we have here. So for this now, what right here in the middle here is the outcome variable. That's what we have here. And the predictor variable is right here. That's the time, okay? And it's used to fit the linear trend. So that is the time right there. So we have this T here, okay? It's what we have here and so we have here. And then we have the outcome variable right here, okay? So we are going to continue. If we use this linear trend equation to be able to predict, for example, we could get this output, okay? This is like, this linear trend is fit to a data from Google Trends, and from here to here is a training, and from here to here is what was forecasted. So this just to show us an example of what the output will look like. We're going to do something like this before the training is over. So that's just to give us an example of what that will look like. That's for the linear trend when we finish forecasting and we plot it. Now for the exponential trend, okay? So the exponential trend implies a multiplicative increase or decrease of the series over time and is captured with this particular equation. So to fit an exponential trend, simply replace the outcome variable y with the log of y and fit a linear regression. So you have something like this. So you can see that from this equation, we are already looking at something similar to what we had in the previous slide on the linear trend. So now for the output, what does it usually look like by the time you plot the forecast and you have your forecast right there. So this is an example of an exponential trend used to forecast a particular data series. That's Amtrak ridership data series. So we are going to be using that data just for the practical section. So this is what the exponential trend will look like. Now, let's talk about the polynomial trend. That's the third one. So for the polynomial trend is a quadratic relationship of this particular form that we have right here. Of course, yt will be equal to this equation. So yt is the outcome variable, just like I explained before. So this is done by creating an additional operator, and that operator t is called t squared. That's the square of t. Remember, our t is the value, just like we have right here. Our t is like that value that we are using as our predictor. So it's the time, it's the periods. Okay, so we'll continue. So we usually have that polynomial trend. We have introduced a t square into that particular, and fitting a multiple linear regression with the two predictors t, like we had before, and t squared, which we just introduced. So for the polynomial trend, if you plot it, it usually looks like this, still on the Amtrak ridership data. So we have some foundation, though there's still a lot more about forecasting, but at least we have a foundation of what, of what tools or techniques that we use in forecasting, and that is enough to lay the foundation of the practical that we want to go into right now. So there are references at the end. I will display it, in the video, where you can check more about forecasting. Forecasting is a world on its own. So I'm going to share my screen for the Excel. Okay, so now this is basically the Excel environment that we're going to be using. First of all, the first data that we're going to be using Okay, so the first data that we are going to be using for this our small practical demonstration is the Amtrak. So we are going to this is the data we can see, just like I said earlier, that time series, just two columns. You have your time value, that's time stamp, and you have whatever you're measuring. So in this case, we have ridership as the measure. So with this now, we can come up with just using a simple line graph, we can be able to model this time series data. Like we said earlier, the very first step to understanding your time series data is to plot a simple line chart, which is what I'm doing now. So I've selected the two columns in the data, and I'm coming right to my Excel sheet here. I'm going to have insert, and I'm going to pick the line chart. So I picked the line charts there, and this is what I have. So this has given us the line graph of this time series data, so we can actually see what is going on right in there. So looking at this, we can be able to say some things based on the components of the time series data that I explained earlier. So let's just pick it one by one and then explain it. For example, we said one of the components of time series data in descriptive analysis is the level, and we said level is the average value of the series. So if you look at this now, we are still going to calculate the average later, but just trying to eyeball it and see which one exactly looks like the average of this series. Okay, we are looking at around the this is in thousands, okay? So we are looking at somewhere around this place as the average. Then when we talk about the trend, what's the trend? We said trend is change in series, okay? That is discernible during this period that we are looking at. So if you look at this trend, we see that even though it's not really you, but it's just a slightly, because it's starting from here, it's coming down a bit around here. I'm just using my mouse to trace it, and then it's going a little bit up again. So there's a slight U shape, okay, as the trend. And then let's talk about the seasonality. For the seasonality, okay, it has a pronounced seasonality. You will see that there are some things that are happening when, you know, this is coming down, it's coming down, coming down, coming down, coming down. But because of the fact that we have plotted so many years in this particular graph now, we cannot be able to see what is going on in the month in each of these years. And so that brings us to what we call zooming, which we will be doing just in a minute. But before we go to that, let's try and see if we can add trend line to this particular, you know, graph and see the trend. So to do that, we will just click. Usually the Excel fits the best trend, you know, to the data. So we can just click on this and go to trend line right here and pick whatever trend line that you feel would be okay. So you can try several. You can try the linear, the exponential, the polynomial, and see which one best fits it. So if I fit the linear now, this is exactly what I'll be having. Remember, I said there's a slight U shape. So there is here, it goes a little bit down. So this linear, even though we have fitted the linear to it, it doesn't really fit it very well. Let's explore some other trend lines. If I try the exponential, it's almost looking like the linear. So I might just want to, okay, let's leave it there and then go for more options. So if you click on more options, you'll be able to actually select some other ones. So that's the polynomial. So I've added the polynomial to it. Now you can see that it bends a little bit in the middle, which is looking like it fits it even more than the linear. So I'm just going to delete this other one so that we can see the polynomial very clearly. Okay, so we can see that the polynomial is looking like it. So that's how you fit your lines to the data. Okay, so the next thing that we want to do now is that we want to zoom in, like I said, so that we can actually appreciate what is going on from January to December in this particular data. We use tools like zooming in, changing of scale to be able to do that. So now let's zoom in into a shorter period. So doing that, I'm just going to, we are through with the trend line, so I'm just going to remove it and then we can do the zoom. Okay, so now we have, so in order to zoom in, let's just filter and have maybe 1991. So for the in order to do that, you just click on this filter here, right here. So you can just remove all first so that whatever you need will be easier to get, because if the years are many, if you want to be picking it, it might just take a lot of time. So now that I've removed everything, I'm expecting, I want to plot for only 1991. So that's, and since the data is in months, so that means I'm going to pick the first 12. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I have 1991 right there. So I can click on apply, and then you can see that we have a better picture of what is going on. So this scale, you can see that this scale has changed now. So instead of having all those years here, we actually have 1991, January, February. So we can see that that seasonality that we talked about, that we said is pronounced, we can actually see the months that it actually goes up. So we can see that the highest, you know, that's 200, that's 2000 right there. That is in August. So we can do that for maybe 2 or more years just to be sure that it's consistent. So if I remove all and I go to maybe 1993, let's try 1993. So we have 1 to 12. Okay. So I can apply and see for, so you can see that 1993, it still happens that 8, that's August, is still the highest. I'm just going to do one more, that's 2001, just to be sure that it's evenly spread. So I'm going to remove all first. Okay, and go to 2001. Okay, so January to December. Okay, so you can see that this is 2001. Even though it's more than 2000, it's still this August that is still having the highest. So we can see that the seasonality is consistent for all the months, for whatever months we are talking about for all the years. So that's an example of how to visualize time series data and actually be able to come out to those components, those 3 or 4 major components that we talked about, which is the level, the trend, and the seasonality. So the next thing that we are going to be looking at is the descriptive statistics. So for this descriptive statistics, but before we go to that, let's just quickly look at changing the scale, because another way to visualize this time series data is to actually change the scale too. So let's just let's replot this graph. I'm going to delete this. And I'm going to plot another one. So covering the whole data. I want to change the scale just for us to see that we can actually change the scale. So, and also be able to discover a few things there. So going back to inserting the line graph, I have this back. So in order to change the scale, I can just click on this. Okay, does it actually come out? So let me close this. Okay. And then I can go to axis and then more option. So I have something like this. So if I have something like this, if I come to, I'm particularly interested in the vertical axis. So I've selected, let me just do that again so that we can get it. So I've come to axis and then more options, and then I clicked on this. Okay, so giving more options, okay, then I come to this place. I'm interested in the vertical value because the horizontal value is for the dates, but I'm actually interested in the vertical value. So I clicked on vertical value right here. That's this place, vertical value. Okay, so this gives me the opportunity to change the scale to logarithm, for example. And so you see what has happened. So that helps you to actually also make some, deductions from the time series data, because when it's logarithm now, it's almost like it's just linear, straight like that. So those are the things that you just want to use to explore your time series data. So the next thing that we want to do now is just still on the descriptive statistics in forecasting. We just want to look at how we can use Excel to calculate the average and standard deviation, and then we move to regression-based forecasting. So for that, I'm still just going to delete this since I'm still using the same sheet. So to do that, let's just remove this. Okay. So now, assuming I want to calculate the average of this ridership, first of all, before I do that, let's just have what we want to calculate right here so that we'll have the result here. And for the standard deviation, okay, So we have it right there. All right. So now this is where I want my average to appear. So I can just say is equal to average, and then I put my bracket there. And I now need to go and select the data that I want to calculate the average of. So I'm just going to block everything like that. I usually like to start from the back so that it ends up, and then I can see my answer immediately. So once I'm through with the selecting, I close the bracket and I can click out. I'll get my average value like that. Then for the, let me just make this a little bit bigger so that we can see what is going on. Okay, so I have my average there, right there. So now for the standard deviation, the same approach too we can use. So we have is equal to STD. So in Excel, the function for standard deviation is STDEV. So we have it like that, and then we have our brackets. So I'm going to go and select from the bottom whatever I want to find the average. So right there. Okay, so I stop right there and I close. So that gives me the standard deviation. So I have these two values. So this, like I said earlier, this gives us an idea of what we're expecting. It should deviate from this. It should be more than this. So when we get an unusually different value or forecast, we know that there is a problem with our procedure. So another thing I also like to say there is that if our data, if it was normally distributed, these two statistics would have been sufficient to describe the demand in future. So we can just say the demand, this is what we're going to have. But that's not often the case. Okay, so we'll just continue. I'm going to stop the screen right here and then we'll go back to our PowerPoint. Okay, so now let's look at, having said that, at least we have been able to see how we do this simple descriptive statistics in Excel. Now let's look at a particular problem which you actually set out to achieve in this short training. Like I said, our goal is to be able to forecast, the future, given a particular pre-event data, and now compare it with what actually happened and see what exactly is going on. So, and like I said, that will help us to actually understand the behavior of our customer. The demand increase if it was a promotion event, or the demand reduce, and how to be able to actually measure it. Not just say, okay, increased or reduced. So actually measure how much and, be able to make informed decision based on that. So for this particular experiment or practical problem that we are looking at, this is the data that we will be using. For example, this particular case problem scenario, we picked this from maybe a suits sales departmental store, or sorry, a store that sells suits. Okay, let's say in Ota, for example, and before COVID, for example, this is the data that they had. Let's say COVID happened around September 2001. So before COVID, they have the data up till, August. And then now, after COVID, you can see that we have more. That's, let's say, COVID, after COVID, which was August, and it continued on and on like that. That's September, sorry, 2001. So whatever happened after that, we now have it up to, that's April 2004. Okay, so, and we have what actually happened. So this is the original sales. So even if you don't have the data and you want to practice this, all you need to do is have a data that has before an event occurred, after an event occurred, probably a particular measure like sales, and the date that is attached to it. So that will give you, that will help you to carry out the experiment. So this original data, just like I was saying, is the total data. That's the real life data of what actually happened in that departmental store. But this is the same data, but it stops before the event occurred, maybe a promotion or an event or whatever kind of event. So the idea in this experiment is for us to use this one, that's the data before the event, to predict what will happen or to forecast what will happen in the future. That's normally what we would have expected, and then compare it with what actually happened and see what actually went down. Yes. So now, what are the steps that we want to use to do this? Okay, we have about 5 steps to achieve this. First of all, we want to split this time series data into 2 parts, which you already have: the pre-event and the post-event. Then we want to use the time series data, that's the earlier one, that's the pre, to plot the pre-event time series, and then try to understand that particular time series data. What are the descriptive statistics, the mean, the standard deviation? Then what time series components appear in the plot? Because that's where to start from. If we know the time series components that appeared, we can be able to now say, okay, let's use a linear, whatever components we have, let's go by that way in order to do the forecast. Then if we need to zoom, we might zoom in on it just to see what exactly is going on there. Remember, at this stage, we're just trying to understand the data. Then the third thing is that we try to fit in a linear or linear, exponential, or polynomial trend to data, depending on which one fits it better. And then fourthly, we now try to, whatever we get from number 3, whatever trend, whether it's linear, exponential, or polynomial, we now try to use it to predict the next 32 months. Then finally, we compare whatever we have predicted to what happened in real life, and then we can be able to make our deductions. Okay, so we'll just start that. I'm going to go back to Excel to achieve those 5 steps that I just mentioned now. Okay, so we're going to take it one step after the other, and we're going to try to solve the problem. So for the very first step, what we want to do, like I said, is to split the data which has been done and to get the descriptive statistics. So I'm just quickly going to repeat what I did for the Amtrak data right now. So I have my mean and I have my standard deviation, just for us to know what is going on. Okay, so let me make this a little bit, it's a little bolder. Okay. So take note of the headings of this. Let me just describe this data briefly. This is the month, this is the period that we talked about in our equation. This is the sales, you know, of the suits. And this sales is in Naira, okay? And this column and this column, they are the same, you can see. But the only difference is that we are having the data pre. We are having the data pre. So this one stops at 171 month. That's about 140 months. That's what we are looking at here. So the continuation. So what the idea is to be able to predict this this balance. Okay. Meanwhile, this column is like the original data. Okay. So that's the original data that was actually gathered in the store, and that's and you can see that that one actually extends. Even so, after even the event, we actually have that data. That's the one we want to compare with whatever we predicted from this one, and then try to see what is going on there. So let's just do the mean. So for the mean, I'm just going to do what exactly I did before. So I'm going to say this is equal to, so I'm going to say this is equal to average. Okay, let me make this bigger so that's okay. Okay. So average of what? I will go and pick the data. Like I said, we are using the pre. We are dealing with the pre now. We don't need the after. It's after we finish the experiment, we just need that one to compare. So I've selected all this and I close my bracket. Okay, let's do that again. Okay, okay. So I can get the average right there. Because for the standard deviation is equals to STD EV and then okay. Then I close the bracket, have my standard deviation. So this gives me an idea of the average value I'm expecting, so it should deviate from this and all that. So now the next thing now is that we want to move to understanding this particular data. So like we did for the Amtrak, we're just going to plot the time series data that's in form of a line graph just to see what is going on there. Okay. So in order to do that, I just made this one bigger. They are the same data so that we could see it better. But I'll just leave it like that. So in order to do that, I might just select, so I can just select, so I want to plot this time series data, this particular pre-event. So I'm just going to select it like that and insert. Okay. So I have my plot right there. So I've been able to plot the suits. That's this, the pre-event data. So if we look at this now, we're already getting the idea that it's like a linear trend. But notwithstanding, we are still going to fit the linear trend line. But before we go to that, let's just still talk about the level. Let's talk about the trend. For example, if we look at this now, we said level is like the average. So we are looking at an average of, okay, let me bring this a bit down. Okay, so we can see that even the average that we calculated said 125, 3, 4. And we can see that the average is just around that, even from this plot. So, and then the trend, what we can see, unlike the other one that was a little bit slightly U, this one is obviously linear and is increasing. That's the global trend. The overall trend is increasing. Okay, like we said, it's the global trend that we use to determine which approach to use. So we can see like there's a global trend now and it's linear and it's increasing. So let's just fit a trend line to this. But before we do that, let's yeah, we can just fit a trend line to it. Okay, trend line. Okay, so we can see that the trend line is linear, so and it fits it almost perfectly. So but also I'm going to remove the trend line. I want to zoom in and see what is happening in the months. So like we did earlier, to do that, we just filter and then remove all the categories. Let's see for maybe 1994, January to December. Okay. Okay, so we can see what is happening there. We still have the August effect. We can try other months too. We can try other months too, maybe like, let's see, 2003 maybe. Okay, we don't have up to that. Okay, so we can try 2000, just to be sure that what is happening is consistent for the years too. Okay, so we apply that. Okay, sorry. 2000. Okay, so you can see that it's almost the same as the 1993 that we tried. So now this shows that there's seasonality and there's something consistent cyclic pattern going on right there. So the next thing that we want to do now is that we now want to get, remember our goal is that we want to predict the next 32 months, assuming there was no COVID. So I'm going to delete this one since we have already understood the time series data to some extent. So I'm going to now try to get the best fit line, because the very first step in your forecasting is that you want to determine, you want to find out the best trend. Then after that, you can now, use that trend to be able to forecast for the future. So since we have discovered that it's linear trend, so let's now get the best fit line. That's using the linear trend to calculate the best fit line. So how do we go about that? Now we have our Excel data. I just want to make everything look the same. I'm going to remove this mean. We don't need it again. Okay, so our data is back to normal. So what I'm going to do right now is that I'm going to create a fourth column right here. So I'll call it best trend fit. Best trend fit. Because that's where we want to put our best trend line. So this is where we want it to appear. Maybe for now, I can just hide this column so that it will not, distract us. So we have it right there. Meanwhile, we still need to insert another column called period. So because we can't use this date as it is like this, we have to create a column called period. Remember the T we talked about the other time. So of course it's still modeling the time. So we just, since it's a month, so we just want to have it in periods. So 1 to whatever is the last. So we have the last right there. So let it fill it with the series. So we have 1 to 1, that should be 140. That's Oh, okay. So now for our best trend line, we select this particular place where we want to fill it up with. Okay. The next thing that we want to do now, we want to say is equal to here, trend into brackets B2. Remember, this is B2. Okay. B2 up till that's B141. I'll show you just in a minute. 141. Okay. So now, and then we close the bracket. Okay, we are not done. We close the bracket and then C, that will be D. This is what we have selected. You can see this has automatically turned to blue. Then the next one here is the period that we created, which is our time. That's the time predictor. So, and this is column D. So D2. D2 to D141. Okay. So we can see it right there. So we are good to go. So after closing the bracket, you can now press and hold your Control and Shift button and then click Enter. You can see. So we have our best trend fit line right there. So it has populated it for us. So the next thing, now we have our line, we are getting close to our forecast. So we can see that the trend, I'm just going to where it ends. We can see that this is where the pre-event data stopped and our trend line has stopped right there. This is the period, okay, which is also the same thing as this time. It's just that we don't want to use it as date. We have used it, we have converted it to periods. So the next thing to do now is to calculate the forecasted values. Remember that this is the pre-event data, it stops here, even though we have the original data, but we need to forecast first before we can compare it to the original data. So calculating the forecast value. First of all, let me just say something. This analysis assumes that the major factors underlying the existing data will remain more or less constant over a number of periods for the forecast. Okay, so we are making that assumption here. So the easiest way actually to calculate the forecasted values is to use a chart to extend the best fit line into one or more future periods. So in this situation, we want to extend it to like 32 months. Okay, and note that to work with a best fit trend line and use it to plot forecasted values, you must plot your data series as an XY scatter plot or scatter chart. And that's what we're going to be doing. So having said that, the next thing that we will do now is to plot that scatter plot. And how do we go about that? Now that we have this our best fit line, I'm going to have to bring this to the front of this. Okay. So I've brought back my original data. And I'm still going to leave this period here. I'll probably just duplicate it here so that we can still have those columns. I still want those columns right there. So okay. So now this period, I brought it to the front here because I want to do a scatter plot and I want this to be right here. So now, having that, the next thing I'm going to do right now is to insert a scatter plot with two columns that I have selected. And what are those two columns that I've selected? I'm going to select my period and this. Okay. Okay. So I have that right there. And I'm going to look for my scatter plot, and it's right here. Okay. So I have the scatter plot. Now, having the scatter plot, I'll click on it to select it. And I'm looking for my trend line. You can see that because it's a linear trend, let's just be sure. Okay, linear trend. Okay, so the linear trend has appeared. So the next thing that I want to do now is to extend it. So going back to this linear trend, I'm going to click on more options. So this comes out. So I'm using linear trend just like it has said already, but I want to extend it for 32 months, 32 periods, since our month is in period. So it stopped at 140. So I want to add 32 more, so making 172. So I'm just going to come right here and change this to 32.0. And also, I might also like to have the equation on the chart. Okay, you can see the equation has appeared right here, and even the R square value. Okay, let's bring it up a bit so that it's obvious. Okay, and as that appeared, we can see that the line, the trend line has extended. Okay, so that is using the trend line to actually look into the future. So the next thing that we want to now do right now is to calculate forecasted values using the linear trend. That's this linear trend that we have gotten. So how do we do that? So we're going to select we're going to come here and select the existing data. Okay. So this is that existing data. Okay. So we're going to select the existing data, click and drag the fill handle to extend the section over the number of periods you want to forecast. So I'm looking at 32, so that should be 32 plus 40, that will be 172. Can drop that. So we can see that it has forecasted it for us. So that's for 32 more periods to the front. Okay. So this is the forecasted value that we set out to get. So just to be able to see what is going on right there, we can actually put We can actually extend this one too. Okay. Okay, sorry. Fill it as a series. So we have up to, okay. So when I did that, I didn't pick it up to, if we add 32 to it, we should actually have 172, but the numbering should be 173 right here. So I left out one. So let's just continue with that. So that means we did 31. Okay, I don't want to do it all over again. So that means we did 31 periods. Okay, so we just left one out. Okay, so that the next thing that we want to do now is that we already have our periods, so 31 periods, and then we have our the forecasted value up until the 31. So the next thing that we want to now do is that we want to now plot and see what, and compare. Remember, this column right here is that's the original data. That's the actual data of sales post the COVID, which is from 141 period right here. So this is what actually happened, and this is what we have. So what we want to do now, let's try and plot it and just compare what is going on. So I'm going to just pick this. So I have my periods. I probably want to use the date, not even the period. So I'm going to select that all over again. Let me just leave out this. So I don't need this one. So I want to plot the line for this. Okay. Okay. So there's a little challenge here. We need to have the dates for 142. That's for all these months. We need to have it here. So I'm just quickly, okay, I should be able to explain that. I'm going to stop my screen and quickly grab those dates and bring it back to this place. Okay, so I'm back. So now we now have the dates complete. So for the beginning to after COVID, post-COVID where the data actually stopped. So we also have the prediction right here, and we have the original data. So I'm just going to select the columns that I need and plot those columns. I've left the period out. Insert. Okay, so this is exactly what we are looking for. So now we have the time plot now. So this blue one is the SUL sales in Naira, which we predicted. But this is exactly the actual sales that happened. That's this color. So we can see that what happened actually was below what was predicted. And I think we can also zoom it so that we actually appreciate what actually happened right here at this point. So, and this point happens to be 2001. So I'm just going to filter 2001. Okay. So we can see that this blue line shows that this is what it was actually predicted to drop anyway, but it's actually now dropped. That what actually happened in real life, it actually now dropped more than it was predicted. So this helps us to actually appreciate it better. So I'm going to go back to the PowerPoint and conclude the short training. So in conclusion, we have been able to go through all these steps, and we have been able to go through all these steps and compare what was predicted with the actual value of what happened. And this event, like I said, is not compulsory that it's COVID. It could be any event that that you want to find out the behavior of customers after that event occurred. Can be used on demand sales and so on and so forth. So these are some of the references in case you just want to read more about forecasting. And we have a training coming soon, October 2020. We have about two actually. One is data science for business success. It's not programming based. We are going to be using RapidMiner, Tableau, and so on and so forth. We have another one that is on descriptive and predictive analytics with R. That one is actually programming based. So if you are interested, you might just want to call this number. So please follow us, like us on our social media handles, and most importantly, leave us comments concerning the training. Thank you.